Hello and welcome to today's lesson on refraction. In today's lesson we will learn what refraction is and why it occurs. We will then examine how different materials and wavelengths affect the degree of refraction. Finally, we will look at practical examples of refraction. So far, you are familiar with the basics of refraction. You understand that refraction occurs when a wave changes direction as it passes from one medium to another, and that the angles of refraction and incidence are related by Snell's law. Building on this foundation, today's lesson will advance your understanding of how and why refraction occurs, and how it can be observed in various practical applications. Let's get started. Refraction is a fascinating phenomenon where a wave changes direction as it passes from one medium to another. This change in direction occurs because the wave changes speed. To understand this better, imagine a car moving from a smooth road, which is a less dense medium, to a muddy road, which is a more dense medium. If one side of the car slows down while the other side continues at the same speed, the car will turn towards the slower side. Similarly, waves slow down or speed up depending on the density of the medium they are entering, causing them to bend. An everyday example of refraction is when you place a straw in a glass of water. If you look at the straw through the side of the glass, it appears bent at the point where it enters the water. This bending occurs because light waves are changing speed as they move from air, which is less dense, to water, which is more dense. To understand refraction more deeply, we need to introduce the concept of the normal. The normal is an imaginary line that is perpendicular to the surface at the point where the wave enters the new medium. The relationship between the wave and the normal line helps us determine the direction in which the wave will bend. When waves move from a less dense medium, like air, to a more dense medium, like water, they slow down. This slowdown causes the waves to bend towards the normal. For instance, when light enters water from air, it bends towards the normal because it's moving from a less dense to a more dense medium. Conversely, when waves move from a more dense medium to a less dense medium, they speed up and bend away from the normal. For example, when light exits from water into air, it bends away from the normal as it speeds up. To make these concepts easier to remember, we use mnemonics. The first one is fast, which represents fast and slow towards, so waves bend towards the normal when slowing down. Then we have safa, which is slow and fast away, so the waves bend away from the normal when speeding up. The degree to which a wave bends or refracts depends on the materials involved. For instance, light bends more significantly when passing between air and glass compared to air and water, because the difference in densities between air and glass is greater. Refraction has many practical examples and applications that affect our daily lives and scientific understanding. Let's take a look at some. Starting with rainbows. Rainbows form because light refracts as it passes through tiny water droplets in the atmosphere. Each wavelength of light bends a different amount, spreading the colors and creating a rainbow. Next is mirages. These are optical illusions that occur on hot surfaces like roads. Layers of air at different temperatures cause light to bend, creating the illusion of water. Thirdly, we have glasses and lenses. Eyeglasses use refraction to correct vision by bending light so that it focuses properly on the retina. Similarly, cameras use lenses to focus light and capture sharp images. Finally, telescopes use lenses to gather and focus light from distant objects like stars and planets. A refracting telescope utilizes a convex lens to bend light rays and bring them into focus, making distant objects appear closer and clearer. In today's lesson, we delved into the concept of refraction and its underlying mechanisms. Refraction is the bending of waves as they pass from one medium to another due to a change in speed. We learned that the normal line plays a critical role in determining the direction of this bending. Using mnemonics like fast and safa, we illustrated how waves bend towards the normal when slowing down and away from the normal when speeding up. We also explored how different materials and wavelengths impact the degree of refraction. Finally, we looked at practical applications of refraction, such as the formation of rainbows, optical illusions like mirages, and the use of lenses in glasses, cameras, and telescopes. Watch the rest of the GCSE physics course at Sophos Education.